Our next session is a viral world. Why viruses are necessary. Pranay Lal in conversation with Ramya Kannan. Perhaps the word most often used in the past year or so is the word virus. Viruses are the world's most abundant life form, and now, when humanity is in the midst of a close encounter with their immense power, perhaps they're also the most feared. But really, do we understand viruses? Pranay Lal's Invisible Empire, The Natural History of Viruses, brings together science, history, and great storytelling to paint a fascinating picture of viruses as a major actor, not just in human civilization, but also in the human body. With rare photographs, paintings, illustrations, and anecdotes, it is a magnificent and an extremely relevant book for our times, when we are attempting to understand viruses and really examining their role in the lives of humans. A quick introduction of the speakers. Pranay Lal is a biochemist who works in public health and the environment. His first book, Indica, A Deep Natural History of the Indian Subcontinent, won the 2017 Tata Lit Prize and the World Book Fair Award, among others. His most recent book, Invisible Empire, The Natural History of Viruses, published by Penguin, presents an alternative view on the role of viruses in ecosystems and the evolutionary history of life. Ramya Kannan is the Hindu's Tamil Nadu Bureau Chief. She is passionate about health and development issues, which she has reported on for the last couple of decades and more. The past couple of years have been devoted to pursuing the SARS-CoV-2 virus in an attempt to make some sense in a world that had descended into chaos. Besides that, Ramya says she is trigger happy, shooting pictures of course, has a green thumb and trying to keep up with her effervescent 9-year-old daughter. Mr. Lal and Ms. Kannan, over to you.
Hello and welcome to the online edition of the Lit for Life event. This year we've gone online just as everything else has. We've heard an introduction to our guest today, Pranay Lal. Hi, Pranay. But he's probably going to introduce us to a teeming, bustling world, that nearly seems like an alternate. It could be a parallel universe, an alternate universe, but in reality, it's nearly invisible. It exists with us. Very much belongs to our world. We're discussing today his fascinating book, Invisible Empire, The Natural History of Viruses. It brings to our vision, to our sight, the world of microorganisms that are generally visible only under a microscope, and seeks to establish a hierarchy virus down. Of course, Pranay, for those of you who are regulars, is no stranger to Lit for Life. His first book, Indica, Natural History of the Indian Subcontinent, was featured at the 2018 Lit for Life event. So, Invisible Empire is really a book that defies categorization. It is science, it is history, it's fascinating storytelling. And I think all of which push this book into a broader and quite indisputable category of unputdownable. So it's facts a minute, it's facts a sentence, but you still want to keep reading until the very end. The book itself, when it is published, we don't have a copy yet, but when it is published, it's likely to be a visual adventure. Just going by the PDF, I can see that it would be a visual adventure. Rare photographs, illustrations, and images that we've probably never seen before, and certainly with this kind of clarity. And it could not have come at a better time, perhaps. A friend of mine, says in jest, the scientist, Dr. says in jest, that COVID has actually been the revenge of science. Everywhere you go, there it is. Far more scientific terms have come into common parlance than you would have thought possible. And who would have thought we've been bandying about terms like RT-PCR and controlled trials and quarantine, remdesivir, mucormycosis on a daily basis. Naturally, an explosion in terms of writing on medicine, research, science, journalistic and non-journalistic has happened. So in that sense, the pandemic, which has changed the world, has also changed things a bit for writing on science itself, don't you think, Pranay? We've sort of moved from the esoteric world that science writing occupies onto, the realm of the popular. And do you think this is like a watershed moment or event or year for science writing or writing on specific topics itself? No, I just wanted to add that now that the dam has sort of burst, do you think that better quality writing, more long form writing is on the way?
Well, absolutely. I think, scientists had written off infectious disease, although we had, major problems like HIV and TB, and we had recurring epidemics and, outbreaks of Ebola and Zika and others that were disrupting, but they were regional and did not grab the attention of the global economic and political order. So this was a big moment of disruption for the entire world. And I think not a single sphere of life was not affected by this. I think even the remotest communities and even communities that were detached from the field of epidemiology were shaken. We saw that economies collapsed. There was widespread migration, as if this was a replay of a film like The Day After or something like that. These were bleak, scenes that we had seen. We saw political systems change. We saw dictators emerge from, what were marginal democracies. I think all those kind of things happened, and this is what we saw in a period of just 1 year. And you're spot on that, science writing had, been pretty staid until now. We were looking at facts and we were reporting on some things like a brilliant paper, and, we presented that. But now I think while the floodgates of data and research has emerged, and, preprints and all those things that were kind of seen very marginal in a form, but people were eager to find out new information about what's happening in the field of, say, COVID research or virology or new drugs and vaccines. All those things became so imminent for people to be informed about that this became perhaps the most educative moment for biology and for epidemiology and public health and all of that. And I think you're right that, we heard things on, jargon that was actually quite difficult to understand before COVID, mRNA, cytokine storm, herd immunity, super spreading. All of this became such a common thing for people to suddenly invest their energies and try to understand this so that they could take better decisions for their businesses, for their homes, for their loved ones. So I think that has been significant. So at two levels of if you were to look at the two ends, whether we're looking at countries themselves or governments, whether governments were able to take better informed decisions and whether the science and the science communication was effective, I think that's a work in progress. I think we made some very, very poor decisions, choice of medicines and how certain countries adopted protocols based on very poor scientific understanding, versus those who did not adopt anything at all and, kind of ignored even the warnings of what the world was actually adopting. It also saw mushrooming of experts and pseudo experts. And I think because of a lack of clarity and objectivity, there was an immense amount of misinformation that happened. And there, as you know, such a huge array of social media tools that actually fan um, information and disinformation. So I think where does future of science writing lie? I think it's got to be in looking at not super specialized reporting, but also looking at objectivity. I think we have to encompass the whole idea of looking at the broad questions, and that's something which I strongly believe in is looking at the broader picture, the spaceman's perspectives of looking at a problem. It's not typically an isolated issue. It's not just ACE2 receptor. It's not just cytokine storm. There are several other things that need to be studied. For example, it's only now that we realize that we now need to start looking at microbiomes of the lung and the gut to understand why certain people develop the conditions that lead to cytokine storms and many others don't. So, those kind of things are related to a larger understanding of what is around the environment, whether it's in an individual's organ or it's outside the world of where the virus lives in. I think clearly there's no answer, but I think what you bring out quite clearly in your question also is that we are living in very interesting times. And I think how we move on from here, whether we as science writers, you and me, or the larger scientific community, the medical community, or the spheres of economics and politics, how do they interpret this very, very massive shock to humanity? How are they going to change their ways in the way they operated before COVID-19 and how they will operate now? I think that's a very serious question. I think we have made some course corrections, but I don't know if these are sufficient because the way we are now moving ahead with a business as usual attitude, I think that is a little perturbing. I'm not sure whether all those lessons have been taken in seriously by the systems who need to have made those changes.
Right. Yeah, that's a sobering thought, and yes, I think to have a larger picture is what this epidemic has taught at least the writers, to be more readable. You have spoken about in your book about the origin of viruses naturally, and the evolutionary leap and the community level reservoirs, and how viruses do stay either in the community or in the human body for a long while, depending upon the kind of virus. So do you think we could sort this out in terms of the COVID-19 SARS-CoV-2 virus? Because it's appropriate, of course, and seems like the thing we should be talking about.
So if I read you correctly, and if I want to cut the chase, what you're asking me is whether I believe in the lab leak theory or whether I
right, exactly. Yes,
well,
yes.
This is something that I said in a talk earlier, and I forget when I said this, that somebody had asked me for a podcast, I think, that whether the lab leak theory is correct. And my sense was then, as it is now, is that if I were to design a virus which was supposed to create chaos the way it has, should I be designing a virus that down mutates or mutates in both ends of the spectrum while becoming more virulent or more benign? Should I be giving it the latitude of doing so? My sense is no. I mean, if I were to create a lab leak which is actually designed to cause mayhem, I would not do that. So it is not a perfect virus. It's not, while it has taken our immune system by storm, it really is not something that I would use as something that can cause the chaos that it has. I would create something more robust and something that is more persistent and does not mutate as much as it has currently. So that's one way to look at it. I think the studies that are coming out now and the two papers that have come out in Nature, both of them have found genomic signatures which suggest that a cousin of SARS-CoV-2 had actually caused an infection about 22,000 years ago in East Asia. So I think we have signatures of previous infections with human populations in Southeast Asia of related viruses. Now, has it evolved since? These are studies that will tell us about, future studies will going to tell us about this more clearly. But I think the evolution of each virus is actually like our own evolution. We are a conglomerate of several creatures put together. We have genes, we share genes with, bacteria, mosses, ferns, banana. Just about every creature has some shared genes with another. So basically, viruses and a few other factors are the ones that drive the piecing of DNA or RNA in the case of viruses that make who we are. So evolution is happening in plain sight. The thing is, we can't perceive it, and it's happening in creatures all the time. Smaller creatures see it more often than, say, certain larger creatures or more complex cellular creatures like us. So I think evolution does not have a trajectory. It's happening in different directions at different scales at different speed, and it's not going to be easy for us to predict anything in the future. But I think we are going to have several iterative steps as we try to discover our relationship with viruses, pathogens, and nature per se. And I think that's where we need to be very clear that viruses or pathogens that we treat as our enemy are enemies, of course, because they take lives. There's no doubt about that. But I think we need to accord them a certain sense of respect or certain sense of giving them a little more importance in terms of their larger role in the ecology or the space in which they operate. So I think that's the thing that has been missing. We've micro specialized in our sciences so much that we tend to forget that there are other things operating together with the microbe to cause the disease that it does. And so why is it that SARS, if the episodes that happen now happened at this time in history and not earlier? These are the questions that we should be asking ourselves. And are there other viruses or pathogens that are waiting in the wing that we should be cautious about? So I don't know if I've answered your question, but I just...
Oh, yes, of course. Certainly. I think it's also sobering, and I think that's where your book really brings the whole world of microorganisms into this perspective, because what we can't see, we don't know about. So, which is why, these theories float around. But it's very interesting how you trace the development of technology on a parallel rather with science. We do know for a fact that, science or medical research rides on technology and vice versa. There is this beautiful intersection between technology and science or medicine that we are seeing increasingly these days, the development of a vaccine over a short period of time and stuff. What does this cohabitation essentially mean for future of science or research?
I think, if you look at science as in, the deep history of science, if we look at Renaissance, for example, I mean, most scientists at the time were not pure physicists or astronomers or microbiologists. I mean, they were savants. They were people with skills other than just having pure science. So if you know, it was called natural philosophy. The whole gamut of sciences were put under a larger discipline called the natural sciences or natural philosophy. And, the great thing about the sciences was that, all scientists or so-called inquisitive people, the curious people, would converge and share ideas about nature and how nature works and different processes and phenomena of nature. And somebody would look at it from the perspective of the physical forces. Some of them would look at it from the geological or the biological forces or chemical forces. So, and there would be intersections that would bring in the best from each other. So you saw a lot of interesting theories that were being propounded around the time when the discovery of the microscope happened, for example, the lenses, actually the microscope came in about 200 years later. But the fact that a polished mirror can be used to enlarge something which was minute, and for the first time when people started seeing things that were crawling on their skin or on a pinch of soil, that's what made people really fascinated about that there was a world there that needed to be explored. And there would be answers to so many things that happen around in nature that perhaps can be answered by these things, the creepy crawlies that you see. So I think the intersection of science and technology, one feeding into the other, has been something that has actually brought incremental innovation to such grand scales. And sadly, like I was mentioning earlier, I think the micro specialization of getting into biophysics and biochemistry and pure technology of making a product, I think that compartmentalization has been a bit of a question mark. And I think people are now trying to say that we now need to go back to the original period of when scientists or curious people together looked at a problem holistically. And I think that whole conversation about getting in the counterfactual, which is something very vibrant in the social sciences, but completely devoid, if I can say that, in science. I think natural phenomena needs to be explained from several sources. If there is something that we see in nature, I think there have to be 2 or 3 or 4 different explanations to the same phenomena. The science is connecting the phenomena to explain it as a whole. To me, that is fascinating. And I think there cannot be a single, simple, linear answer to anything happening in nature. So technology is a good diagnostic tool now, which kind of serves answering the questions of science, the ones that science raises, and science in turn provides a feedback on how technology can be improved. While that is fine, the larger questions of what makes science work is something that I think needs revisitation. And I think this moment in history is one where we are going to be looking at how we want to change the way we read science, we explore, or we communicate science. I think that's going to be a very, very critical moment on how we want to move from here now.
Right, that's a wonderful idea. And basically that is the scientific spirit, isn't it? It is the scientific temper and the pursuit of science. And maybe another book waiting in the wings for you on that. But so relatedly, at some point in your book, you indicate that, why our virologists might have just scratched the surface, tip of the iceberg, as it were. To quote you, the only thing we know for sure is that we don't know enough about the viruses. And even for something as complex as the human body, we have the Human Genome Project, which is, possibly mapped the human genome. How and when are we going to figure out the viruses? Do we have a timeline? Are we going to have a virus genome project? Something similar. What do you think?
It's going to be a mammoth task that we try to understand all life forms that have existed or exist now. It's going to be just too complex. I talk about 2 viruses that live in one in the ocean, the other in our body. And the most prevalent creature was not discovered until 1988. And that's the organism which Sally Chisholm at MIT, when she was doing her PhD, discovered. And this is a very tiny photosynthetic organism called Prochlorococcus. It's found in the first 8 meters of every ocean and sea, and also in some ponds and lakes. Now, this creature alone, which we hadn't discovered till the time it got discovered in the late 80s, produces and consumes about 22% of all carbon and produces 22% or roughly about that much of oxygen. Now, without this knowledge, we would not know that we need to preserve oceans. Oceans even now are dumps, right? So if you really want to correct climate change, you have to look at that creature. And that organism, Prochlorococcus, depends entirely on the life cycle, its own life cycle and its relationship with viruses, marine viruses that kill it. And I talk about this macabre dance that takes place between the viruses and this bacteria, and how delicate this process is. You eliminate the virus and you have a thick pea-like soup, what we call algal blooms. You have that proliferating all over the oceans. And while that consumes a lot of carbon dioxide and produces oxygen for a moment, it will kill the oceans. And eventually, there's going to be a massive oxygen climate crisis, oxygen carbon dioxide-led crisis. Another organism which I talk about is a virus that's found in our gut, and that's a critical organism because it maintains the gut health. Now, if that virus is eliminated, you would have bloated stomachs and bacteria taking over your gut. All those things start over. Just like the ocean, where it goes and spirals into chaos, your stomachs could also go into that kind of a chaos. So viruses are everywhere, and they are something that we don't know about. Now, this virus that I'm talking about, the one which controls the population of the bacteria in our gut, was discovered only in 2014. We didn't know anything about it, right? And even now, our understanding of our microbiome, the gut bacteria, the organisms that live in all over our body, including our blood, or even our brains. There's a virus that has been discovered that stays inert in our brain, and we don't know what function it serves there. But what appears to be a Rip Van Winkle kind of a situation for a virus, just staying inert for generations and generations, they do play a role because there is something that they modulate in our genes, or they regulate the entry of other viruses. We don't know what they do. And I think that learning is going to be immense. And I think you're right that, the fact that we realize now that we know so little and that we now need to move forward from here is a good start by itself. But I think we must stay humble when it comes to nature, and when it comes to the most humble creatures like the microbes and beetles and anything that we call germ. I think you must have seen that tirade that I've done closer to the end, where I say, let's stop calling creatures germs and bugs and critter. And, I'm just appalled when scientists in particular, or science communicators, use those words. It's so insensitive because you are categorizing creatures that have utility in other ecosystems, but you dismiss them because it has no anthropogenic function. Now, how limited, how naive can scientists themselves or science communicators themselves be? I think we now need to leave behind that, and no creature should be called by any of those names that we have called them. I think we need to have a very, very respectful. I don't know if that is the term, but I think we need to have a more sensitive way of dealing with or even annotating creatures and life forms.
Right, absolutely. And, it segues into my next question so beautifully, because not very long ago, when in one of my earlier stories, I called COVID, SARS-CoV-2, a wily virus, right? And, of course, as usual, there was a hullabaloo on Twitter, and people said, scientists sometimes, I wonder. So they said, oh, it is, what are you saying? It's just a strand of RNA. How can it be a wily virus? It does not have a life. It doesn't even have a life. But, when I read your book, I was like, yes, because I was delighted to find, some justification for my use of this. You've described viruses variously. You've called them brilliant, you've called them crafty, you commented upon their mastery, industry, and even, you've even said rhapsody. So do you think that viruses have character?
I know you've actually put me in a spot of bother, because I know a lot of people would be gunning for me for this as well. You know, I think, how viruses modulate, as populations around them change, they tend to respond to those. And later they tend to control, because they infect and they decide to, kill a few of the hosts in which they infect, and some of them they just persist for a longer period, and perhaps emerge or do other things. So it is a very variable world, and I think I'm very conscious of the fact that viruses now need to be called a life form. I know that they are inert and near dead when they're outside a host and they exhibit nothing. They're just a coat of protein with an RNA or a DNA inside them. But think about it. Once they spring into life, once they're into a cell, they have such majesty, and I think they are in complete command, right? I mean, these are verbs and not value attributions. I think what I'm trying to say here is that we must accord them the status of life form. That's the first thing. The fact that we classify them and give them names, we don't call them protein 1, protein 2, right? I mean, initially we did, but no longer. I mean, we have names and species name and everything. In fact, they have a more specialized taxonomy, a classification system than any other creature. Now, having said that, the challenge remains that should you be according them epithets of the kind that you mentioned? I think, yes, they do. Why not? Because it only adds value to our understanding of what do we anticipate when a creature or a life form were to exist in a certain condition in an ecosystem. So I think wily is, I would not support that point, because they're not directed, or they do not possess directed intelligence. I think they tend to evolve looking at the conditions around them. They are programmed. So if you want to call a program intelligent, then yes, they might be intelligent. They can also be wily in that case. But I think it's what the response of their wiliness or their their ingeniousness is because of what the conditions of the hosts are at the time and how they respond to populations. So I don't think people should be so readers or listeners should be so prickly about you and I using the term wily or anything, or even rhapsody. For me personally, when I see a bacteria or a virus or even a nematode under a microscope, and the way that it behaved, it contorts, it moves, it does its own usual dance, I find that fascinating. So for me, I would use those epithets because I admire the beauty in them. I don't find them, the typical things that we call them, germ, critter, bug, all those things I think are derogatory, and I don't think need to be put in. So it's genuine love for me, for which I accord them these epithets or these qualifications. So I don't know. I think it is very context based, and I'm not sure whether, when we are doing journal writing or serious communication writing, we should avoid wily. But when we are speaking the way we are now, I don't think it is so wrong. I think I was corrected once when I was talking about dinosaurs also, that, they are terrible dinosaurs and they're, extremely voracious eaters, but it is a term which is relative, right? And I think what makes them voracious at a certain time would be the environment, or the fact that, if they're feasting on a carcass, they would be behaving that way. So I guess it's not something that we, I think by using epithets of the kind that we do, I think we are humanizing them and not anthropomizing them. I don't know what the term is, but something to that effect. I don't think there's anything wrong, because it brings in or accords them that value that they're alive. And I think I'm fine with it. Lots of people are not. I know my editors are not fine with it. They asked me to tone that down. So yeah.
Right. And in that, I think lies something that we were talking about, readability and basically taking science to the people. If you don't humanize it, then are people going to get it? I mean, will your book be as unputdownable? If you completely left his turns out. I don't know. I mean, it's a question that we could ask. So if you were given at some point of time Kafka's powers of metamorphosis, which virus would you want to be? I mean, okay, we'll say, let's not say virus. Which microbe do you want to be? You know, the rhapsodic kind? What would you like to be?
That's a tough question. You know, somebody who loves viruses and bacteria and chlamydia and protozoa and nematodes and, you know, anything microscopic, I'm just hooked onto that. So it's a very difficult choice. It's like saying, me asking you, which is your favorite rock song? I mean, it's easy to say, which is your favorite rock band? That's simple. But once you come down to saying, hey, listen, you need to tell me the species, the song, that particular song, that becomes problematic, right? So I'm not, I don't know if I were, now again, I would, give myself the latitude and say, hey, listen, if I were in soil, I would like to be, the phage that kills Ralstonia, which is the most pathogenic agricultural crop bacteria. It's perhaps the highest ranked agricultural pathogen that is listed in the Bioterror Act of the US. So if I were to, I mean, actually, there was a scare in the early 90s and until quite recently that if somebody were to take a special new strain of Ralstonia, this thing that was actually found in the soil of Brazil, it initially could infect only about 20 species found in South America, but as crops started to go all over the world, it started to infect local crops as well. So now they believe anything between 400 and 500 species of native and exotic crops get affected by Ralstonia, and it's massive. It is so you would see obliteration of papaya, tomato, pineapple, which are in a mixed agroclimatic condition, but in a single farm, which is supposed to be protective. But in case of Ralstonia, it is indiscriminate. It would just go and decimate every crop that comes on its site. So I would like to be the phage that kills Ralstonia. But since I've said bacteria, now I've said about virus, what would be my favorite bacteria? You're going to hate me for this, but the organism that causes syphilis is called Treponema pallidum, is extremely beautiful. It looks like golden necklaces under a slide. It's beautiful. It looks so nice. It looks like as if you entered a jewelry shop. Not that I'm fond of gold or jewelry, but the fact that you're seeing it lit behind, in a slide when the light is coming from behind it, and the golden color of the bacteria when it comes out, it's quite heavenly, if I can say that. And it's a disease that is, the disease it causes is very painful and obnoxious. But I still quite admire the beauty of that bacteria.
Right. So I think this, in this answer is your entire book in a capsule. You see how much you love these microorganisms, and it comes out very beautifully in the book. I really enjoyed reading, and I must say, like I said earlier, my 9-year-old daughter read portions of it with me on the Kindle. And she's fascinated. This is the age where they start to become trivia buffs, and they love facts. So she really loves the book as well. And I think you should take a suggestion to do a kid's version at some point of time. More pictures and illustrations, and I think that will be lovely. So do consider that. Thank you so much, Pranay. I think we've had a lovely discussion, and I think there couldn't have been a more appropriate discussion or a book for the times we live in. Thank you so much.
Thank you for having me.
Thank you so much for this fascinating discussion on the world of the viruses and why we need to be empathetic and sensitive to them, and in the way we actually refer to them, and to also recognize that we know so little about them, and it's about time we get to know them just a little more.